this is another example of the deadlock. Okay, consider the execution of four processes P1, P2, P3, P4. So there are four processes in the system and two resources R1 and R2. Clear? So processes P1, P2, P3, P4, these are the priority. Priority is given. So high priority process means it will execute first. Okay. So every process, this is the execution sequence E, R1, 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 E. So R1 means resource 1, R2 means resource 2. Okay. So it will execute in one time unit, like E will execute for one time unit, R1 will execute for one time unit. Okay. But if the resource is occupied by one process, then that resource cannot be used by another process, right? Okay, so let's start. Okay, now which process will execute first? P1. Okay, because the arrival time is 0, right? So at 0 time P1 enter into the system. Clear? Clear? There were no any other process except P1, right? So at 0 time P1 process enter into the system and start to execute, right? So P1 will start to execute at 0, right? So P1 first will execute E. E means execution, okay? So up to 1, clear? So P1 will execute 0 to 1 E, right? So E is executed. Now P1 will execute R1, right? So P1 will execute the resource 1 up to 2, right? So R1 is executed, clear? Now at 2, two new processes entered into the system, clear? So P1, P2 and P3, now three processes are available into the system, P1, P2 and P3, clear? So P3 has high priority, so P3 will execute first, right? Now this is P2 and this is P3, right? So P3 will start to execute at 2, 2 to 3. Okay, so P3 will execute E, right? Sorry, this one, E, right? And P2 will go to the waiting state and P1 will go to the waiting state. Okay, only one process can execute at a time, right? So if P3 is executing, another process will go to the waiting state. Clear this point? Okay, now P3 will execute again because no any other processes enter into the system at 3. Okay, no new process enter into the system, right? So P3 will execute again. So P3 will execute R2. So P3 will execute R2. Okay, up to 4. And P2 will go to the waiting state and P1 will go to the waiting state, right? Now at 4 another process enter into the system, P4, clear? So at 4 P4 entered into the system. Okay, so P4 has high priority, clear? So P4 will start to execute now. Okay, so P4 will start to execute at 4 and it will execute E, right? Okay, clear? And another process will go to the waiting state, right? At 5 there were no any new process entered into the system, so E will execute again and another process will go to the waiting state up to 6, clear? Okay, now P4 want to execute R1. Okay, but R1 is already occupied by the P1, so R1 is not available. Okay, so if a process want to execute a resource but that resource is not available, so the process will go to the blocked state. So the process P4 is blocked now. Okay, because the resource is not available. P4 want to execute R1. Okay, and R1 is not available because R1 is using by P1. Okay, so R1 is busy. Clear? Okay, now at 7 these P3. Now the process P4 is going to the blocked state. Okay, right, and there are three processes in the system right now: P1, P2 and P3. Which process will execute? P3, because P3 has high priority. Okay, so P3 will start to execute again. So P3 will execute R2. Okay, R2, and other process will go to the waiting state. R2. No, because same process. Okay, so R2 is already busy with P3 and P3 want to use R2 again. So P3 can use, right? Yeah, right? Okay, now at 7 P4 will go to the blocked state again because R1 is not available, and P3 has high priority still, so P3 will execute E again. Okay, and then P2 will go to the waiting state, P1 will go to the waiting state, right? Now P4 is still blocked. Okay, and P3 exit because P3 already executed all the execution, right? P4 is still blocked because P4 want R1 to execute and R1 is not available. Okay, see, there are two resources R1 and R2. Okay, so R1 is busy with P1. Clear? So R1 cannot be used by another process. If another process want to execute R1, then that process cannot use R1 because R1 is already busy. For example, you want to print. I'm printing on the printer, okay? And you want to print. So you have to wait until I finish my work, okay? You cannot print in between. Clear? For example, there is a road. Road is a resource, okay? And one car comes from this side and another car comes from another side, okay? And road just one, single road. So both the process cannot execute the resource, okay? But if one car is going, okay, and another car want to go on the same time, so that car cannot go. Okay, for example, there is just one bridge, okay, and one car can go to the another side, okay, and then when bridge is free, then another car can go to the another side, right? Like this, okay. So if the resource is busy, then another process cannot use that resource. Clear this point, right? Now which process has the high priority now? P2. So P2 will start to execute here. Okay, so P2 will execute E, right? And another process will go to the waiting state. right? At 10, the process P4 is still blocked, okay, because R1 is still not free. Now process P3 is finished, okay, so P3 is finished its execution and it exit from the system, right? Now there are two processes in the system, P1 and P2. So P2 is still has high priority, so P2 will execute now, okay, and P1 will go to the waiting state, right? Okay, so P2 is also finished. P2 is also finished its execution, right? Now there are just two processes in the system, P1 and P2. Sorry, P1 and P4. Okay, P4 has high priority, but P4 is still blocked because R1 is not free, right? So P4 is still blocked. Then P1 will start to execute again. So P1 will execute R1, okay. Then P1 will execute R1, right? So R1 is finished. Now resource R1 is available. Clear? So when resource R1 is available, then process P4 will start to execute because P4 has high priority. Okay, so now P4 will start to execute from 12. So P4 will execute R1 first, and then it will go to the waiting state and it's finished, right? So up to 13, then R2, okay, up to 14, and then E, okay, because E also P4 will execute E because P4 has high priority, so P4 will execute E up to 15, okay. Then the process P4 is exit from the system, right? Now there is just one process in the system, that is P1. So P1 will execute now, okay. So this is waiting and P1 will execute now, okay. So after that all the process exit from the system, right? So in this question you have to determine which process was blocked during the execution. So the process P4 was blocked during this whole the execution from 6 to 12. Okay, so process, you will write here, process P4 was blocked uh, from 6 to 12. Okay, this time 6 to 12 the process P4 was blocked, okay. So I can ask the question like what is the waiting time of P1 during this execution, okay. So what is the waiting time of P1, okay. So what is the waiting time of P1? See, count the W. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the waiting time of P1 is 11. The waiting time of P2 is how much? 1, 2, 3, 4, 5, 6. 6. Waiting time of P3 is 1, 2, 3. Okay. And the process P4 was blocked up to 6 times. Okay, so this is also the waiting time. In this time the process P4 was not executed. Okay, so P4 was waiting resource R1 up to 12. Okay, so 6 to 12, it's like 1 2 3 4 5 6, 6 times P4 was waiting the resource R1. Okay, so the P4 waiting time is 6. The average waiting time is equal to 11 plus 6 plus 3 plus 6 divided by 4. Okay, so 1726 divided by 4, 6.5. This is the average waiting time. Okay, P3 wait here. Oh, yeah, yeah, yeah. Yes, yes, you are right, you are right. Okay, so it was written wrongly. Okay, uh, P3 execute E, then R2, then R2, then E. Khalas. So P3 was finished their execution at this time. Okay, at 8. Okay, so the waiting time of P3 is just 2. Yes, you are correct. The waiting time of P3 is 2. Okay, so this is 25, so 6.25. Okay, so this is the waiting time for this. P4 waiting time, yeah. P4 waiting time is 6 because P4 was blocked at 6 to 12. Okay, so P4 was waiting resource R1. When resource R1 is available, then P4 will continue. So what the waiting time of P4? P4 waiting time is 6, right? Okay. Still, first process, resource. Yeah, yeah.